Hello everyone, this is Shubham. In this video, I'll be teaching you how to use relativity in this concept of falling objects. Alright, so consider there are two objects, right? As you can see here, there are two balls in orange color. One is upside and another one is on the ground. Okay, so this ball is on the ground. So let's name this as ground. And let's say the distance between these two balls from here to here is nothing but 2 meters. Alright, now the question over here is, let's say this ball is dropped and this ball is thrown upwards with an initial velocity of 5 meter per second. All right. And this ball falls with initial velocity of 0 meter per second. All right. So the above ball falls with initial velocity as 0 and the bottom ball is thrown upwards with a velocity of 5 meter per second at the same time. Okay. Both are thrown upwards and downwards at the same time. So when these two balls will meet? When the two balls will meet and at what time? Right? So this is the question with us. Now we have to find the time and we have to find at what distance as well. Okay. So here how we can use the relativity concept is, first let's understand what do we mean by relativity. Okay. So for example, there is one guy, he is moving in this direction with, let's say, 2 meter per second, and there is this another guy, his friend is jogging and he's moving in this direction with 1 meter per second. All right. Now consider this as person A and this as person B. Okay. So what will be the velocity of B with respect to A? Right? So velocity of B with respect to A is nothing but 1 minus of minus 2. Now why we are doing this is because if right hand side direction is positive, then left hand direction would be negative. Basic sign conventions. All right. So it is 3 meter per second. All right. So the velocity of A to B, right? What will be the velocity of A perceived by person B is 3 meter and same for A. This is called as relative velocity, right? So can we say this is equals to VAB? Yes, it is. All right. So using the same concept, what we can do is when this, let's consider this upward motion is positive. Okay. So downward motion would be negative. And these two balls are moving under the influence of gravity. So there is a constant acceleration. Constant acceleration, that is G. And here for our convenience, we'll take G as 10 meter per second. Now, what we have to do is consider these two balls as one system. Okay. So what will be the velocity of these two balls? Okay, as a system, right? As one system, as one ball. So it is going upwards. So we call this as ball A and we call this as ball B. So now what is VAB? VAB is nothing but 5 minus of minus 0, which is nothing but 5 meter per second. All right. So now you remove this B and put it over here. All right. So now as a whole system, A and B is combined. So here is the ball. Okay, so V, A and B both are combined. Now it has to cover how much distance? 2 meters. Okay, so since the acceleration is constant, so I can say distance is equals to speed into time, and therefore distance is 2 meters. And we know the fact that speed is 5 into time, and therefore time is nothing but 2 divided by 5, which is 0.4 seconds. All right, so the time taken by these two balls to meet would be 0.4 seconds. All right, friends. Okay, now let us see at what distance they'll meet. So we got the time. Now, why are we using distance is equals to speed into time? This is when there is a constant acceleration. So here we have already said it's a constant acceleration. All right. Now I know what is u and I know what is time. Okay, so we have to find distance now. So therefore, what we have to do is s is equals to ut minus half gt square. Why minus? Because the system is going up. Both the balls together is going upwards, so gravity is acting downwards. Okay. So now s over here is S is what basically we need to find. All right, so we have S is equals to initial velocity is 5, time is 0.4 seconds, minus G is 10, 10 by 2 is 5, and 0.4 whole square. So basically this is nothing but 0.4 into 5 is 2, minus 5 into 0.16. 5 into 0.16. 16 5s is nothing but 80. So we basically get 2 minus 0.8, which is nothing but 1.2 meters. Okay, so from the bottom 1.2 meters somewhere over here, at this distance of 1.2 meters, the ball will meet here. From the bottom, from the ground, at a distance of 1.2 meters, they will meet. Right, friends? So this concept is very, very easy. Now, in this particular case, the B ball, right? The ball B is having an initial velocity of 0. If this would have been, let's say, for example, 5, right? Then the relative velocity of both the balls would have been 5 minus of minus 5, that is 10. Okay. So I hope, friends, you like this concept. Thanks for watching.